everyone, my name is Ajana Williams and I'm going to be doing my presentation on the performance analysis of cracking attacks using Hashcat software. So I'm going to break this down into a few sections. The first section is going to be about passwords, where we identify what weak and strong passwords look like. Then we'll be going over hashing and how passwords are hashed. After, we'll go over Hashcat and basically an overview of commands and techniques. And then we'll implement those commands and techniques, and then we'll go over the results of all of those attacks, and lastly we'll do the takeaway. So first, what are weak and strong passwords? So a weak password, it looks something like this, that's easily guessable. You'll see that anywhere. I've heard it a million times. This is something that's in the middle. So it begins with a name, and then it's followed by a year, and that could be when someone was born, probably Peter himself. And then this is a strong password, which is a combination of uppercase and lowercase letters, numbers, and special characters. So more specifically, what are weak passwords? So if it's short in length, it's probably weak. When you're trying to sign up to create an account on a website, they most likely won't let you enter a password that is less than 8 characters. Words from dictionaries are also very weak. So a dictionary doesn't necessarily mean from the book. A dictionary is basically a list of passwords. So password and then 1, 2, 3, 4, 5, 6 are common passwords that are found in dictionaries. If it's easily guessable, like if it's a sequence of the numbers 1 through 5 or the letters A through F, if it's a common phrase or information, like your name or your birthday or something that's readily available that anyone could just find on the internet. If it lacks complexity, so it doesn't have any numbers, special characters, or uppercase letters, then it's pretty weak. If it repeats characters or sequences, such as like 0000 or 1, 2, 3, 4, ABCD. If it contains your personal data, which is basically personal data such as names and birth dates, that's also weak. Or if you use things that are known, like by default, which is like, again, password or admin. And then what do strong passwords look like? So if they're long, 12 characters is pretty long, but like that's pretty strong as well. If they're complex and have different types of characters, if they're unpredictable and avoid common phrases and personal details, if they're unique and you don't use them across multiple platforms, if they're common patterns, you shouldn't do like, again, the sequences. You can also do like a phrase. So I use like, here's Johnny, which is like a famous quote from The Shining. You could put that in there. Or if you enable two-factor authentication on an account, that makes your password stronger. So what is hashing? What does passwords have to do with hashing? So hashing is basically an algorithm that takes a plain text and then it puts it through a hash function and then creates an output. So this is the output of the word password using an MD5 function, and there are several different types of hashes. So how does the MD5 function work? So it's pretty complex, but I'm going to give you guys the bulk of it. So first, it takes whatever word you use and it appends padding bits to it. And then it takes length bits and append those to the password as well. And then it initializes an MD5 buffer, and then it processes each 512-bit block, what does that mean? So let's get a little deeper into that. So like the previous example, if you take the word password and it is 100 bits long, you're going to have to add 472 padding bits to that 1,000 bits. And that basically makes it exactly 64 bits less than an exact multiple of 512. So let's get a little deeper into that. So if you add 472 padding bits and it becomes 1,472, that's exactly 64 bits less than 1,536, which if you divide that by 3 is 512, right? And that matters because in the next step, when you append the length bits, you're going to append those 64 bits and then make it exactly 1,536, excuse me. And then from there, it's going to be broken down. So each of the 512 bits are going to be broken down and ran through 4 different buffers. So in this example, I just used these 4 buffers. And then from there, each of the 4 buffers, so each of the 512 blocks is going to go through the 4 buffers, and then it's also going to use different array values and subblocks, and then it's going to go through 4 rounds of 16 operations. Each are completed for a total of 64 operations for each 512-bit block, which that sounds insane because it is. And then it creates outputs like these. So we just went over MD5. So for the quick brown fox jumps over the lazy dog, this is our output, and it will be different for each different type of hashing algorithm. So in this case, for SHA-1, this is the output, and for SHA-256, this is the output. Same input, but different algorithms. So what is Hashcat? Let's go over that in an overview. So Hashcat is a well-known and efficient password cracker that is frequently used by system administrators, hackers, and spies, in addition to penetration testers. There are different versions of it available for Mac OS, Linux, and Windows. So how does Hashcat work? So a lot of people think if you give it a username, it'll just give you a password, or if you just give it a hash, it'll crack it. But it's a bit more complicated than that. So hashing algorithms are known as a one-way mechanism, so they can't exactly be decrypted. So instead, Hashcat takes a word, which you give it that word, and then it hashes it, and then it compares it to the hash that you give it. So if I give Hashcat the password, and it hashes it, and it doesn't equal what I have given it, the hash, then it won't crack that hash, if that makes sense. So let's go over the syntax of Hashcat. So Hashcat, it has different methods to cracking different hashes, and it does it different ways. So it has several options. So there are different types of hashes. Those are MD5, SHAs. There are different attack modes, which you guys may know about some, like brute force attacks, dictionary attacks. There are also different versions, and there's like the help mode that you run when you're trying to when you need help from Hashcat, and they give you helpful tips on what you're doing wrong. So again, just to go over the different hash modes, the hash modes are very extensive in Hashcat. This is only like a portion of the list that's available. So in the attacks that I'm going to be showing you guys today, I'm going to be using MD5 hashes, which is hash mode 0, and I highlighted it here. I'm going to be doing it's going to be a raw hash, so it's not going to have like too many salted hashes and things like that. There are also different attack modes. So as previously mentioned, they do have a dictionary attack. Hashcat references it as a straight attack. There are combination attacks. There are brute force attacks, which Hashcat refers to those as mask attacks because brute force attacks are outdated. There are hybrid attacks of word lists and masks, mask and word lists, and then there are also association attacks. So when masking attacks are being done, or hybrid attacks, we're going to use a character set. So blown up here are the different type of character sets, the different type of characters that can be made into a set. So I'll go into more detail on this later, but when referencing any of these, like a lowercase letter, I'm going to use L. An uppercase letter, I'm going to be using U. A digit, D, and so on. So when I give Hashcat basically a parameter or argument, in this case, which is called a character set, I'm going to be using these letters as a reference. Let's see. So Hashcat also provides examples of what an attack would look like. So for example, if I was running a word list attack with rules using an MD5 hash, my attack line would say Hashcat-A0, which refers to an MD5 hash, and then -M, which refers to a straight attack, and then I'll include my hashes, my dictionary, and then rules. And then, of course, this is what it looks like for like a brute force attack, a combinator attack, or an association attack. So, what do these actively look like, these attacks? So, to even begin, it took me a while. I had to first install Homebrew, which is basically a software package manager, and it installs all of the software that your device doesn't originally have, and it's specifically for Mac OS. So with Homebrew, I was able to install Hashcat, which then allowed me to do the attacks that I will be showing you guys. So first, beginning Hashcat, I used the command line above, which is brew install Hashcat. This makes sure that brew was the one that was directly receiving my command. Homebrew also updates itself. So whenever I need to download something new, it's updated so that whenever I'm ready to do so, Homebrew is readily available to download it. And then it also reviews the memory I have available for the attacks, and it all puts it in the output so that I can see what changes I need to make. It also goes over the different attack modes and whether or not you'll be able to complete them. So originally I was running through this problem where I didn't have enough space for my attacks, which is something that I fixed later on. But for example, it was like showing like for MD5 the speed of the attacks and how quick they would be. So it went through this several times, of course going through the same things, different types of hashes like decrypt, MD5 crypt, where it was basically telling me like the hash mode and whether or not I was capable of doing those hashes. So after getting my memory together, I started my first straight attack. So a straight attack or a dictionary attack is basically a simple word list attack. So each word in the file is used as a potential password. So in implementing any attack in Hashcat, you need a few things. You need a word list, which is a list of passwords, and you'll also need a hash list, which is a list of hashes. And then in a straight attack, each of those words is hashed and compared directly to those hashes with no funny business in between. So my command line for this attack was -M0, which is MD5, -0A, which stands for a dictionary attack, and then I specified exactly where my hashes were. So my command line said /users /AJ, which is me, /download /Hashcat /MD5 hash.txt. So that was exactly where the file was, because you kind of have to direct Hashcat as to where things will be. And then I also had to do the same thing and give Hashcat a word list, which Hashcat refers to as a guest space. So the targeted hashes, which is the hash file, is used and matched up against the guest space to crack each password. So in the end, I was able to crack passwords, several passwords, and the output looks like this. So it shows you the hash and then what the password is directly next to it. And in total, I was able to recover all of the passwords, which progress, of course, says 100%. Hashcat provides like a summary of each of your attacks after you complete them. So like it'll tell you the time started, which I started this at 1 p.m. on Wednesday, October 4th, and then it estimated that it would take 0 seconds, and instead it took 6. There were no salted passwords. It says I cracked out of all 5,071 of the digests, which is another word for hashes. So after that, I went over to do a mask attack. So a mask attack or brute force attack tries every possible character in the 95 printable ASCII character range against each hash. So it basically does exactly what a straight attack does, but it does it in a bit more order, like a bit more organized. So my command line for this attack was similar to the one in my straight attack, except I changed my attack mode to 3, and I added this at the end. So Hashcat has this thing where if you try the same attack more than once, it won't give you an output because it already cracked those hashes. So you had to attach a pot file disable command so that it'll reiterate what it already did and it'll give you your output. So I just want to show y'all what it looked like doing this attack. So again, this is the mask attack. The attack itself was a bit longer than what this video shows, and that I'll explain a bit later, but we'll just see the first few seconds. So you guys may notice that it'll randomly like stop and then it'll keep going like here. So it's kind of breaking up because it's cracking passwords of different lengths. So when you're doing a masking attack or a brute force attack and you don't give Hashcat a character set, which I'll do later after this, it'll crack those hashes in order of length. So first, when it first skipped, it had just got done cracking all of the 5-character passwords. And it took about 3 seconds to do that because 5-character passwords are very short and simple to crack compared to longer ones. And so that was about 8.72 of all of the passwords I had, which is about 442 total. And then once it skipped, it moved on to the 6-character passwords. So this one took a little longer because as the passwords increase in length, so does the attack. It took about 1 minute and 25 seconds. And now in total, including the 5-character passwords, I cracked 2,298 of the passwords. And then it moved on to 7-character passwords. So that's when it was getting a little lengthy. So in this case, it took 51 minutes and 22 seconds to crack those. And at this point in the attack, I had cracked 3,535 of those digests. And then it moved on to 8-character passwords. So at this point, my computer's getting a little hot. It's getting a little slower. I'm noticing that this really isn't going too far, too fast. So I ended up canceling the attack. But in my case, it would have taken a day and 8 hours to complete the attack, which I had other homework, I had other things to do. I couldn't leave my laptop sitting for a day and a half. But in total, I was able to reach 3,907 of those passwords, and it was about 77% successful. So that is just a regular masking attack and what it looks like without parameters. So I did the same attack, but instead I gave Hashcat a character set or a mask. So just like the previously mentioned character set that I had referenced, I gave it, I guess, an argument, you could say. So arguments, they can look however you want them to look. So these are just examples of what I could have done. So if I wanted Hashcat to look for a password that was 7 lowercase letters long, like the name Michael, I would do a question mark and then a lowercase l and a question mark and a lowercase l. And then I would just do it, a lowercase l, 7 times, each of them with a question mark before it. If I wanted Hashcat to look for an uppercase letter, a password that has an uppercase letter followed by 4 lowercase letters, 1 special character and 1 digit, like Jesus is number 1, I'm going to do something a little different. I'm going to have U for uppercase followed by 4 L's and then an S for a special character and D for digit. And then if I wanted Hashcat to look for a password with 3 lowercase letters and 3 digits, like mom123, it'll do the same, similar to the ones before with 3 letters and 3 digits. So in my case, I added the parameter that I was looking for a password that was just 7 lowercase letters. Now, I could have done something a bit more complicated, like seen before with the different digits and the special characters, but the success of those attacks when I tried to do them was very low. Like it got like 1, 2. So I wanted to do something where it was going to be at least semi-successful. So after adding this character set to my command line, let's see, this is what I got. So in this video, you can see me giving the command to Hashcat. So I always start each command line with Hashcat, so that command goes directly to that software. And then I followed it by -M0, which is MD5, and then -A3, which is the current attack mode that we're in. And then I give it a list of hashes and a list of passwords. And then here you could just see that it was cracking those passwords. Now it did take a few minutes to do, so we're just gonna go over the output. Am I losing my mind? Let's see. Okay, sorry guys. So it was able to decipher 18.64% of the passwords. So in total, 945 of them were just 7 letters, like no special characters, no digits. So then I moved on to a combination attack. So a combinator attack combines words from 2 dictionaries. More specifically, it appends words from the second word list to words from the first word list. So what does that mean? So what if I had 2 word lists, right? And in the first word list, which I just named it wordlist.txt, there's these 3 words, star 12, 1, 2, 3, 4, 5, and angel 1. And then the second word list, wordlist2.txt, I have family 4, blue 32, and mom of 3. Hashcat will take each of these 3 passwords and amend it to each password in the first list. So it does that and creates, I guess, these super words and compares it to all of the hashes. So my command line also looks a bit different in this attack, as I have to use 2 word lists. So after adding my first one, I added my second one, making sure to name them differently because, you know, you don't want to confuse yourself. So so this is another screen recording of what my desktop looked like on my laptop. And it looks a bit different because I actually had to click and drag my word lists and hashes into Hashcat just to make sure that it was reaching the right places, because this attack is a bit more confusing. So you saw me add the hash list followed by the first and second word list. And then, just like before, I'm adding pop file disable because this is one of those attacks I had to do a few times myself to make sure I was doing right. So I implemented it a few times, and then just as like a tester, and then this was like me knowing I had did it the right way. So let's see. So yeah, that was the attack in real time. It was really fast. But let's see, it was semi-successful. Let's see. Okay, so it was pretty successful, as it cracked most of the hashes except for one in just 11 seconds. So let's see. And then I moved on to rule-based attacks. So in a rule-based attack, which is basically a hybrid of a word list and a mask attack, the goal is to reduce the quantity of password guesses to an approachable chunk of the total possibilities by appending a rule to the end of a word in the word list. So what exactly does that mean? So this attack looks like most of my attacks. Of course, I changed my attack mode to a wordless plus masking attack, but then I added this at the end. So just like previously mentioned, when you add a character set to your password attack, I added $D, and it's at the end next to this word list because the mask, as you can see, is second, and that basically means that Hashcat is going to look for words with 2 digits appended to the end. So the placement of where you put the character set is also important, because if I put it here, it'll look for passwords with 2 digits at the beginning, which we will see later. Here's another one, another video. So in this attack, like previously mentioned, I'm gonna ask Hashcat to find me a password with 2 digits at the end. Of course, that's gonna be a few passwords because it's common to put numbers at the end of a password. So let's see. So showing these, my main goal was to make sure that everyone was seeing the attack in real time, because although it does sound complicated, because it is, it's also very scary how uncomplicated it is. So a few of these attacks, even though it took me a while to learn them, it took only a few seconds to execute, which shows, I guess, the seriousness of this application and what it could do, because that's how easily it can break into a real user's account. So just so we could see it to the end, it was able to crack 3.37% of the digest in just a few seconds. So let's see. Okay, so yeah, I was able to crack 171 of the 5,071 passwords in just 7 seconds. And then, like before, this is going to be a mask plus a word list attack. So the goal of this attack is to also reduce the quantity of password guesses to an approachable chunk by putting a mask at the beginning of the attack. So this one's different from the last one because I moved it, the 2 digits that were originally here, I moved it to the front of the word list. So now it's going to look for passwords at the beginning that had 2 digits at the beginning. And so, let's see. This attack was also pretty fast. Because Hashcat knows what to look for, the attack does become quicker, which I'll also discuss later. Let's see. So I changed my attack mode to attack mode 7, which is the last type of attack that you can use in Hashcat. And then I'm going to add my hash list and my word list. And then from there, let's see. So as y'all can see, it took me longer to type the command than it did for Hashcat to solve it and give me the passwords. So again, it was pretty fast. 28 of the passwords had 2 digits at the beginning, which most of them were all numbers, not followed by any letters at all, and that only took 5 seconds. So here's a little recap of what we just did. So in total, 2 of these attacks were 100% successful. Now, that in real life is very unrealistic. In my case, I made sure that my password list or my word list or dictionary list perfectly matched up with my hash list in these 2 attacks. They were my testers. Now, this was also pretty unrealistic because, again, my hashes and my passwords, they matched up. Now, my mask attack with the character set and then my 2 other mask attacks, that's more of what a real attack would look like. So when a hacker or a pen tester or a system administrator is using this application and they add character sets to a random set of words they have compared to a random list, then this is more so what it's going to look like, because of course not all of those hashes is going to match up with the words in that list. So the takeaway, so what does this even mean? So passwords less than 8 characters are dangerously insecure, which is something we knew, but something that Hashcat was able to reinforce, because again, whenever I tried to complete my mask attack without parameters, it basically wouldn't even solve the ones that had over 8 character passwords, or would have taken a very long time. And that is because today, brute force attacks aren't really used, since passwords that are more than 8 characters are almost computationally impossible to crack. Adding special characters to a password makes it more difficult to guess. So if a lot of these passwords, if they only had digits or only had letters, Hashcat was able to solve those and crack those pretty fast compared to the ones that had special characters. So in this case, this was my word list plus masking hybrid attack. Only 3.37% of those passwords had 2 digits at the end, which isn't in the majority. So special characters placed at the beginning of a password are more secure than those placed at the end. So most people are going to place digits at the end of their passwords than at the beginning, because human nature makes us very predictable and we kind of do the same things. So if you put digits at the beginning of your passwords, you're in the minority of people that are going to have easily guessable passwords. So this is a screen recording of my laptop again. So when I was doing these attacks in the first place, I needed to find a word list somewhere, a list of common passwords. So as I'm searching, I find a list on GitHub, and apparently GitHub has dozens and dozens of lists, and this is actually where I got some of my passwords. In this list alone, there are 100,000 passwords, which even though you may not think your password is on that list, it may be, and those lists are constantly being updated, and there are many different types of them. So you should probably, reassess your passwords often, because, well, you never know when your password might end up on that list. And so in my search, GitHub was only one of the few websites I had found. So this, again, is a screenshot of GitHub. This is actually the website I originally tried to use, weakpass.com. It has several different word lists, all of different sizes. This one here is actually 104 gigabytes. So that's way bigger than the 100,000 I originally found on GitHub, and I couldn't even download it because the list was that big. This is actually another website called Dictionary Assassin, where they sell you word lists. So those word lists are exclusive, so I don't even want to know what's on those. The more information, the quicker the attack. So that basically means the more information that a hacker has about your password, the quicker it is going to be for them to crack it. And this was seen in all of my mask attacks, where if I knew something had 2 digits at the end or the beginning, like in this case, Hashcat was able to crack those in just a few seconds. Or in this case, in my regular mask attack, it was able to crack 18.64% in just 10 seconds, and those were all the 7-letter words. Questions?
How long did it take you to learn to use Hashcat?
Okay. So from September to October, it took me about 2 months to remember. a lot of the commands and how to use them and do them independently without help, which is actually very scary because Hashcat, even though it's something that can be used by the good guys who are just trying to assess their passwords or the security of their networks, it can also be used by people who are genuinely trying to get into accounts, which is why it's very important to make sure that your passwords aren't common and everywhere else and on different accounts.
I have a question.
Yes.
Can this be used to hack into user accounts?
Yes, it actually can. So it's a bit more complicated on that end. So I was able to figure out how to use Hashcat and crack hashes that I already had with passwords that I was able to obtain. In the case where you're trying to hack into user accounts, you have to essentially find that user's, the hash of their password. And so when you sign up, like for example, when you sign up for a website, right? Like for example, you're making an Instagram account and they ask you for a password, and then let's say you lose that password and you don't remember it. And so you're trying to click like find my password, reset my password. They won't give you your password because they don't have it. They have the password's hash. So if someone can find that hash and they have a good word list, then yes, they can use it to crack into user accounts.
I got a question.
Mm-hmm.
What do you plan to do now that you've learned how to use Hashcat?
So now that I know how to use this, it's a little dangerous. I feel a little dangerous now. I think I'm gonna like go a bit more into what I previously mentioned with the previous question. I think I want to learn how to extract hashes myself so that I can use those to crack actual passwords from actual accounts. Now I don't plan to do that independently. I hope to do it at a job somewhere legally in an organization where I'm getting paid to do it. But yeah, I hope to work more on the back end of Hashcat and learn to extract hashes myself and perform these same attacks. Anything else? Thank you. Thank y'all. Thanks for listening.